Hello everyone. In this video I'll be discussing the chemical reactions of alkenes. That is, the first chemical reactions was hydrohalogenation, means addition of hydrogen halides to the alkenes. Now, ozonolysis. Let's check out the ozonolysis reaction of alkenes. Now, ozonolysis of alkenes involves the addition of ozone molecule to alkene to form ozonocyte first, and then there's cleavage of the ozonite by zinc and water molecule to smaller molecules. Now let's check out the reaction of ozonolysis. Now ozone is this is our ozone molecule. Now if we take an alkene here, when it reacts with ozone in the presence of zinc and H2O, there will be formation of aldehyde, and there will be formation of aldehydes. Now, how does this reaction takes place? Now, let's check it out. Now, when this reaction, now if we C double bond C, H, CH3, and then H. Now when react with ozone O3, now this is our carbon, first carbon. In the ozonolysis of alkenes, both the double bonds breaks up, and then we begin. This is our CH3 for this part, H. This is also our H, and then H. Now these are O3 molecule, therefore O3, the first O, second O, and then our third O comes and bonds up in this way to form our alkene, to form ozonite. This is an ozonite molecule. Now when zinc along with H2O reacts, now what would be our direction here? When zinc reacts with H2, this bond breaks, and then this bond breaks. Now therefore there will be formation of this group one, CH3, C double bond, now that means CH3, CH. Since there is breakage of two bonds, double bond O would form here, and then plus for this CH2, CH, H, and then since the bond broke up in this form, there will be formation of double bond here. Now therefore acetaldehyde, this is acetaldehyde and formaldehyde. Formaldehyde is formed in the process when this is in 3 carbon atoms, therefore when propene undergoes ozonolysis reaction, formaldehyde and acetaldehyde is formed. Now what happens when 2-methyl-butene undergoes ozonolysis reaction? Now what is 2-methyl-butene? Now let's write the formula for 2-methyl-butene, CH3, CH double bond C. No cells. 1, 2, 3, and 4 carbon atoms, therefore butene double bond, unsaturated double bond, therefore it will be any butene. The double bond is on the second carbon, therefore butene, and then the methyl group is also here on the second carbon atom, therefore the 2-methyl-butene. Now when it undergoes ozonolysis, what is the product form? Now a short trick for this ozonolysis reaction is a simple trick. Now just take ozone here and then break the bond in this way. If you break the bond in this way, you would be getting CH3, CH. For the since this bond broke up for this part, you CH3, CH, CH double bond O, and then for the second part you'd be getting here carbon CH3, CH3, and then double bond O. Therefore now here a ketone along with acetaldehyde. This is also known as acetone. A ketone along with acetaldehyde is formed when our 2-methyl-butene undergoes ozonolysis reaction. Therefore, in the exam, the question may be here: what is O3? This is AO3, Zn, H2O, and then they would be give the product here CH3, CHO, along with CH3. C double bond there, CH3. This is our acetone, this is acetaldehyde. What is the starting reagent? That is A. Therefore, we know that our starting reagent would be our 2-methyl-butene. Now, a short trick method as to how to know what our starting material is now just join it up. We know that this is CH3, and then RH is here. This is our acetaldehyde, and then our ketone is here. Double bond C, CH3, CH3. Now just remove these 2 oxygen atoms, and then you'll be getting here our product. Remove the 2 oxygen, the double bond would form here, and then you'd be getting our 2-methyl-butene. So for this is a short trick method as to how ozonolysis reaction takes place. Now let's check the third chemical reaction of alkenes, that is addition of sulfuric acid. Now in this reaction, cold concentrated concentrated sulfuric acid is used. Cold concentrated H2 is concentrated acid is added to alkene according to Markovnikov's rule, that is the H plus joins with the carbon atom having more number of hydrogen atoms. Therefore CH2 double bond CH2. This is a symmetrical alkene. Now when sulfuric acid can be written in this form, HO is double bond O H. Now sulfuric acid H2SO4. So therefore these are sulfuric acid molecule. Now oxygen atom along with the 2 bonding electron goes here, therefore there will be release of the proton, this electron, and a negative charge would be formed here. Now this hydrogen attacks 1 carbon atom, and then the whole group would attack the second carbon atom. Therefore this would become CH3, 1 bond breaks up, CH2, and then O, it has bonded with O, SO2, and then our OH would come in, and therefore this is known as alkyl hydrogen sulfate. Now this reaction is also this is the formation, since it has come and bonded up with the hydrogen atom, the first one hydrogen atom, and then CH2, and then SO2, O. It has bonded with this oxygen atom, has bonded with the second carbon atom, therefore it would be SO2, and then our OH is here. Therefore this is known as alkyl hydrogen sulfate reaction. Therefore in the addition of sulfuric acid also has occurs in accordance with Markovnikov's rule even for unsymmetrical alkenes. Now if we take an unsymmetrical alkene here, CH3, CH double bond CH2. Now when this reacts with sulfuric acid, HO is double bond 0, double bond oxygen O, and then this goes here, this will be released as a proton, this become negative charge. The H plus attacks the carbon atom having more hydrogen atoms, therefore it would attack here, the S would attack here, therefore our product here would be CH3, CH O, SO2, OH, and then this carbon atom would become our CH3. Therefore these are the chemical reactions. These are some of the chemical reactions of alkenes and the addition of sulfuric acid to alkenes to form alkyl hydrogen sulfate.